Nice to see you again. Thanks for joining me for section 6.5.3 on elementary column operations. So although we've not used them so far in our course, elementary column operations do exist and they can be used in evaluating determinants. And the three elementary column operations are the complete analog to the elementary row operations. We can interchange two columns, in which case we would write column I interchanged with column J. We can multiply a column by a non-zero constant k, so k times column I, and lastly we can multiply one row and add it, one column and add it to another column, so ci plus k times cj. Theorem 6.5.2 is also an analog to a theorem that we had for row operations. So if B is the matrix obtained from A by interchanging two columns this time, then the determinant of B is negative the determinant of A, so absolutely the corresponding result. If C is the matrix obtained from A by multiplying a column by K, then the determinant of C is K times the determinant of A. And if D is the matrix obtained from A by adding a multiple of a column to another column, then determinant of D is equal to the determinant of A. So the absolute analog of the theorem that we had for row operations. Example 6.5.3, if we're told that the determinant of this matrix is -7, we're asked to do the determinant of this matrix. Now, we've done an example like this before with row operations, but we see here it looks like column 1 and column 3 have been interchanged. So we can evaluate this new determinant by doing some column operations. So let's switch those columns back. So we'll do column 1 interchanged with column 3. Put down my equal sign. I get a negative out, and so I'm going to have A minus B, C minus D, E minus F, and G minus H and I. Now we've got negatives happening in both a row and a column, and it looks like something strange in the middle, but actually if we factor out a negative, we'll see something that kind of clears up that middle, which doesn't seem to have a negative on it. So let's factor out by doing a column operation. Let's do minus column 2, which brings out a negative. So if I have a negative, I'm going to end up with a positive. So those will cancel. Positive. And the negatives coming out of column 2. So A, B, C minus D minus E. Now when I pull out a negative, E becomes negative, and minus F. And that clears things up for us. G, H, I. So we're one step away now. Now we have a row that has a negative in it, and there's no reason that we can't mix columns and row operations, as long as we sort of do them one step at a time and don't overlap and make things confusing. So we can do minus row 2, and that will pull out a negative again from that row, and so I will get the original determinant back, A, B, C, D, E, F, G, H, I, and so the determinant that we're looking for is negative of this one had the value of -7, so negative 7 is just 7.